Good morning, professors, and welcome to a new video on the Science Bus. I am Barbara Di Cicco, and in these videos, in collaboration with Wasibo, I will show you some experiments that can be conducted with the Science Bus. In today's experimental demonstration, we will discuss the methodology to ascertain the elastic constant of a spring from an empirical perspective. For this purpose, we will require the mechanics kit, and it is an experiment that is appropriate for students in the first 2 years of high school. Let's secure ourselves into the elastic foundation. We carefully and meticulously insert the smaller rod into the clamp and securely fasten it. Subsequently, we insert the rod on the opposite side and ensure it is tightly secured as well. Initially, we will proceed to calculate the elastic constant of the spring within the dynamometer. Therefore, we take a dynamometer, for instance, a 5 Newton dynamometer, and verify that it is accurately calibrated to 0. Then we suspend it on the rod. Utilizing a ruler, we then proceed to measure the resting length of the spring that is contained within the dynamometer. We proceed to acquire a 50-gram weight and cautiously suspend it from the apparatus. Thereafter, we meticulously measure the ultimate length of the spring when it attains its equilibrium state. In this manner, we are able to compute its extension, denoted as dx, which represents the disparity between the concluding length and the original resting length of the spring. The system remains in an equilibrium state given that the mass is stationary. This implies that the cumulative sum of the forces exerted upon it must equate to 0. In actuality, the gravitational weight force directed downward is counterbalanced by the opposing elastic force. The two forces possess equal magnitude yet are oriented in opposite directions. Thanks to this specific equation, we can thus ascertain the spring constant with accuracy. To be more exact, from an experimental standpoint concerning the computation of the spring constant, we conduct the experiment repeatedly with a variety of different masses. Let's move forward by doubling the mass. I shall add an extra mass with a weight of 50 grams. Let's then calculate the new final length attained by the spring and subsequently recompute the elongation. We can additionally amplify the mass by a factor of 3-fold, and by determining the length of the spring obtained in this particular circumstance, recalculate the elongation and examine the subsequent changes. We can furthermore represent the data that we have meticulously gathered in a graphical manner and observe how the elastic force is directly proportional to the elongation of the spring. We possess the capability to replicate the same experiment by utilizing the 1 Newton dynamometer. The subsequent step will involve calculating the elastic constant of these alternative springs. To successfully accomplish this task, we take a spring and carefully measure its length while it remains at rest. We meticulously take a 50-gram mass and firmly attach it to the spring. We patiently wait for the spring to come to a complete stop from its oscillating motion and then proceed to precisely measure the final length that the spring eventually reaches. Through this particular method, we are able to accurately ascertain the elastic constant of the spring. We can clearly observe that each individual spring possesses its own distinct elastic constant. Indeed, we have the capability to suspend the identical 50-gram mass on these additional 2 springs and observe how their elongation distinctly differs in each of the 3 scenarios. By carefully measuring each of the 3 springs, we can accurately calculate the elastic constant. To be more precise and find the elastic constant of a specific spring, we can change the mass. Initially, by utilizing a dynamometer, we ascertain the gravitational force applied on this particular mass. Following this, we affix it to the spring and compute the extended length of the spring in its ultimate state. We then replicate this procedure for supplementary masses. Professors, thank you, and we'll see each other at the next experiment. Goodbye.